So, well, very good morning to students. Today we are going to learn about the in-situ stress measurements. Means, uh, so far, earlier lecturers, you are all are aware of the samples collected from the underground mines and the core recoveries and taken into the preparation of samples later that put into the UTL and take the universal restitution under pressure. How much the different tensile compression, triaxial, point load, protodiagonal, washability character of these all are by the laboratory test and implementing a model to the underground. But sometimes you require the institute stress measurements also. Institute stress measurements directly you are go to underground and tested by the stress relief and stress restoration technique. So many techniques are used for a reality in that called in situ stress measurement. So today topic also related to this one. Uh, that is in-situ stress measurement, particular stress relief and stress restoration. This is the underground mine view of a mine for a sample collection of the other one. So technique for measurement of in-situ stresses. Stresses can be measured in borehole on an outcrop and the walls of underground galleries. Uh, Three of best known and most used techniques are hydraulic fracturing, flat chop method, overclock. These are the three methods are important for the technique for measurement of institute stresses. So, relative importance of the experimental process in the rock mechanics investigation. The corresponding important to measure with reasonable accuracy the property of rock and the stress, strain, and deformation in the structure. Although although it is the most axiomatic that any kind of measurement should be made reasonable accuracy. This statement has particularly significant in rock mechanics because unlike many of older established branch of instruments, measuring procedure have experienced the test of that. Most of the instruments of the rock mechanics compared to recent oil that instruments are commercially available for measurement of rock investigation have either designed and built modified existing equipment. Need of particular problem what happens lacks standardization because of the individuality. Only the more functional aspects of this class are applicable to this class. Usually, the construction details can be found appropriate the end of the chapter. Descriptions of other institutions, those instruments and methods that they have demonstrated satisfactory performance in the actual use. Many of the rock dynamics instruments reported in the literature were adopted built to operate in a specific environment under the special circumstances. The engineering and cause details using many of these instruments in a different environment under the other operating conditions. without first calibrating, otherwise checking it on the intended service condition. Also, a number of instruments have been described. The lack of an adequate calibration is indication of accuracy. So the in-service satisfactory response cannot be the general rule. The condition under which the instrument has been calibrated should be thoroughly exposed compared to the intended service condition. Now, so definition and concepts. So, come to the number of words and concepts of these instruments and procedure for measuring stress, strain, displacement, and deformation that have specific rules. To avoid ambiguity, these words and concepts are different explain that. What is the mean by deformation? That will come into the coming slides. So each of these techniques have their advantage and disadvantages. These techniques expert pressure and disturb rocks to create a response that can be measured and analyzed. They are explained in the next slides one by one. Hydraulic fracture. This technique is performed on a dam, on overshores, buildings, etc. It is designed for the cable to relay. In a hydro fracturing, the decision is taken from shunt in the pressure, and shunt in pressure is defined as the pressure which exerted by the water in borehole will become equal to the resistive force as a called shunt in the pressure. So mechanism. The rock is cracked by pumping water into a borehole. The known tensile strength of the rock is infrared and concentration of the stress and the well bore are processed to yield the initial stress in the plane perpendicular to the borehole. Increases in pressure burst the walls and final pressure PS give you the safe passage of the tracks for the pressure and zero. So after the process of factor safety are applied by the formula. Get there. So just before we go to the flat jack method, uh, there is a deformity sensitivity is important. The sensitivity of deformation measuring instrument is defined as the smallest increment of the measurement of a quantity that can be read on the indicated scale. For an accurate road scale, read with the unaided eye, the sensitivity is about 0.01. However, many instruments apply some kind of magnification to improve the sensitivity, which may be a mechanical option, electronic applications, etc. With the smallest increment of the length that can be read on the scale of the deformation devices, and then magnification is here. Then the deformation sensitivity of this device, uh, strain sensitivity and deformation sensitivity. Deformation sensitivity also measures the strain gauge. That is, if the deformation is divided by the gauge length, the starter sensitivity instrument is make accuracy. So many ranges are there. They will be selecting the strain gauge and deformator for specific measure of the range. Instrument must be constrained, which is defined as the maximum quantity of instruments can measure. Uh, Reproducibility and accuracy because of friction lost motion. A sensitivity instrument will not be giving exactly the same value in the successive reading. That the readings are not exactly reproducible. The most probable value of the an experimentally determined quantity is the arithmetic, which is the sum of the individual readings divided by the number of readings. If the number of readings are large, the average approaches the true value of the measurement. However, neither the sensitivity nor the reproducibility is an indication of the accuracy of the instrument. The accuracy of an instrument can be determined by the measuring or comparing against known standards. So some instruments are calibrated by the manufacturing and are followed with the calibration certificate. Others, such as a micrometer, are supplied with the standard secondary standard. Instruments developed in the same research laboratories are usually calibrated against a primary and secondary standard. The accuracy of an instrument is often expressed as a percentage of the maximum measuring range or some arbitrary value within the measuring range of the instrument. Those, if an one micrometer has been calibrated by making success rate, so calibration standards found a proper statistical method of the accuracy within the plus or minus 0.0002. So 0.02% measurement the errors are. There are two type of kind of instruments errors are there, random and accidental. So and systematic also. So accidental error, systematic, random errors of which equal probability may be positive or negative within a spectrum. True error. And many caused by the factors such as a friction of lost motion because they are random. Errors tends to average out sufficient number of movements are taken and data are created such that the systematic errors are consistently either positive or negative with respect to the, and they can be evaluated only by calibrating against a standard. Systematic errors caused by factors such as physical damage, loss of calibration, temperature, humidity, low bacteria, external to the errors that are inherent to an instrument. Other errors may be using by the observer. Errors in judgment or carelessness in reading. It may cause random error. There is a personal bias may cause of systematic error. The instrument and personalizers combine to give the measurement error. Mistakes in the recording data or in making calculation, repeating the calculation. So, coming to the strain or stress relief, the distinction between absolute and relative measurement has a special significance in the rock mechanics. Like most engineering structures generate from the material that are initially unstressed structures. The rock are made with the material that is initially under stress. If, say, a strain gauge is installed on a mine pillar and the mine area around the pillar increase, thereby increasing the load on the gauge will be indicated increase. The strain measurement is related because of the initial state of strain in the pillar was unknown. However, if this pillar is cut from the mine roof, the pillar strain will be reduced to zero, and gauge will indicate the absolute increase in the strain. Furthermore, this measurement strain within the sign reverses the absolute strain that existed in the pillar before it was cut. The process of the cutting is a part of the strain structure, free from the it's a surrounding referred as a strain relief. The strain leadership pillar rock is known. The absolute stress can be calculated and processed referred to the stress relief. In fact, the term strain relief and stress relief are used almost synonymously. Most of the procedure for measuring absolute deformation, stress and strain continue require a partial and complete strain. So coming to the that deformation measuring instruments are there, relief measurement instruments are there, linear variable differential transformation, borehole transformations are there. Coming to the flat jack, the stress restoration. The flat jack is a completely hydraulic cell flat jack system, you can say. This techniques is applied on the rock face, subsurface rocks, uh, subsurface rock. This technique is applied to the rock face, subsurface rock. Rock faces are found in a tunnel, mining or excavation in this method. Points are marked on equal distance uh, depending on upon the tenor method. When the mark is completed, then bolted is applied. Plots or gauges are attached after bolting with the help of the hammering. The microfracture that are developed by hammers are given by attached cage. The rock is partially unloaded by the cutting slot and then reloaded. The in-situ stress normally the slot is related to the pressure required to null the displacement that occur as a result of slot cutting. This technique is used to identify the tensile stress. It is also applied on the rock face. Borehole is made on the rock face. The gauge are installed in the hole. These gauges are give us a result that how much is the hole change its diameter or shrinkage of diameter. Diameter is increased by trimming. So trimming is done on the one side of the hole is increasing the diameter. Then the change in the stresses is checked, resulting in the low pressure due to the increase in the volume. These are the other general procedure. Just to elaborate. So generally, these are institute stresses, magnitude, the magnitude and orientation of institute stresses vary considerably within the geological system. The pre-existing stress state change uh, dramatically due to the excavation, construction. Therefore, load must be redistributed. Success in not familiar. It is a tensor quantity and tenor are not encountered in everyday life. It is a means to analyze mechanics behavior of rock. It serves as a boundary conditions in rock engineering problems. As a stress state is applied for the analysis and design. It helps in understanding groundwater fluid flow. A large scale shed some light on the mechanism of causing a technique plates to be move on the fault rupture. Within the added uncertainty in that there is no constrained load force as the cause of the gravity loads. The plate's motion and interaction at the plate boundaries and within the plates or at the driven by techniques forces, the magnitude and orientation of the forces have changed over the geological force and faults created in a response to the force from the past approach, volcanic instructions, etc. May all have been involved in the creating the current heterogeneous systems that is now subject to the current tectonic region. The problem of the design in the rock complained further by the fact that structural features such as joints, fractures, and bedding planes can be have an important influences on the ability of the rock mass to resist these forces on the strength of the rock mass as a measuring over the region often if a lot that is affected by the structure the, the could have an adverse influence of the strain across the structure such as a result called die contact and are major joints. Then in-situ stresses, there are variety also shown here. There is a earth crust movements are there. The stress conditions often may change significantly across uh, the structure such as a fault like content and a major uh, stuff for geological matters tends to the attract stresses so that the stresses dike may be higher than in the rock such as a quartz and close properties. The effect may be influencing the vertical stress to the some of extent. The effect of the topographic on vertical stress depending on the height of the hill or valley. The relation to the wealth, the effect of the holding, effect of the faulting, earth crust, bench, ocean, 6 meters deep continental crust.
ocean crust have been formed within the past 200 million years. There is a containment contain rock, which are more than 3.9 million years. So the theory of plant techniques are continental drift age, earth crust is cracked into a series of planets. They are moving around the earth surfaces. Continental expand of higher material and they are rest. Theory of plant distribution over earth crust are cracks into the series of plants which are moving around the earth surfaces. The content are compared to high material and they rest upon the moving plates. The plates ridges occurs along the mid-oceanic ridge where new crucial rock is being added in a molten material well in one of the below. Effect of the plant movement, the oceans are widening the spreading at the rate of 1 to 10 centimeters per year. The earth is not expanding, crust is being destroying at the plate's edge, ocean edge. So these are plate tectonic movements for explanation purpose. Right. Insitu-stress to oral stress maps are there. These are the stresses developed in various regions in the plate tectonic movement, other conditions also there. They are grouped into the four category: earth focal mechanism, well uh, breakout and dealing with these features. This is stress measurement, overcoming hydraulic fracturing. Major uh, Pacific plates, Arctic plates are there, Northern American plates, Southern American plates, African plates, European plates, and Indo-Australian plates. Evidence for the continental drifting is similar for rock sequences in the southern continent is similar of the coastlines. The typical evidence is from the local glaciers. So this is a sample given. The foundations, all the concept of sample experience, personal experiences, everything, and the logical chemistry is not under the formation professor philosophy university Japan. So these are the uh, rock structure illustration of the complete nature of the material. Former Yugoslavia, these are others in the rocky countries. Rock engineering way, engineering construction where and variety. View is given. So highway and other features will have been blasted in the rock. The above two photographs are showing this type of engineering. Naturally, here are many examples of rock engineering. Underground of these occurs in the civil engineering projects. Rock dominating countries and touring underground mining in all countries. Obligations and roads and railways tunnels can have quite different appearances depending on the engineering and architecture affiliation. The two photographs and figures, the contrast is shown between the tunnel that required no lining, so that their job visible and the tunnel that required extension support. There are often occasions when small or large surface excavations are. In spite of this diagram, we discuss major rock mechanics experts in the individual basis of the techniques for measuring institutions already given. That does this is already given. So overcoring is technique is also there. These are another different technique. Coming to the basic ideas of coming to the hydraulic self flat jack. Flat jack is a thin walled bladed container designed in a withstanding by hydraulic pressure in several thousands of pounds or which when properly confined by cementing or grounding. Then in a borehole or slot in rock, these cells are used for the variety of purposes rock mechanics. So investigation including the measurement of forces, joints for load, a mine pillar for applying force to instrument, the pressure transmitters and the pressure sensors. These cells are fabricated by forming two identical halves out of the malleable sheets metal and bridging or welding of the half together. A copper brass made steel has been used for this purpose. Fabric construction cells for use in borehole. The maximum pressure that cell will be withstand depending on the number of factors, the type of thickness of the body, whether the bridging or welding technique. Even more important, depending on the quality of the gravity, the care exercise in the preventing the formation of void during installation of the cell. Uh, Actually, the flat jack, the thin hydraulic cell, referred to as a flat jack, first developed for presenting concentrated or otherwise the loading part of the concept structure. Uh, the typical 12 by 12 inch cell mode of the 1 by 16 mild steel with an electronic welded joint and grounded in a slot within an expanding type Portland cement sand ground with stock pressure. Falling that cause of failure was attributed to the rock rupturing. Although pressure is the cell is the temperature depending on the variation temperature rock is usually. small that the source of error can be negligible. Except for the possibility of leak, they are not difficult to prevent. Hydraulic cells have good stability long period of the particular. These are the one type of instruments. Another instruments are specific borehole cameras, borehole television cameras also there. And then the LVDT also there. Another dynamometer load cells are there. Dynamometer whole load cells are instruments for measuring forces load. In rock mechanics investigation, they have been used for measuring load, props or shocks, tension, development of rock load, and pressure on the given area, developed backfill in or caved area. Uh, these are the visual photograph observation boreholes also there. That is the purpose of the linear LVDT is the most linear variable difference transform is configured for the convert small displacements with change in the electrical current. The devices are available in a variety of sizes ranging from less than the several inches with the displacement measuring ranges. So the transform consists of primary point and secondary points. Within the which there is a movable iron supplied in the primary and if the iron core is essential used to voltage in the secondary coils equal opposite. If the core is displaced in either direction from the center position, the unbalanced voltage distribution secondary is proportional of the core displacement essentially. The differential voltage in the secondary independent of the frequencies in the specified operating frequency depending on the voltage of the linear variable differential transformation process desirable quality mechanicals. It will be unaffected by the ambient temperature and humidity changes, and the measurement range is large when used with the sensitive vacuum voltage. Sensitivity of the rod of temperature can be achieved. On the other hand, the output for the transformer is proportional to the voltage, and is the accurate regulating voltage like must be used because the devices will be permitted remote operation, particularly sensing elements in the formative design of the installation area that become necessary for the unsafe during the course of the measurement. Strain measuring instruments also there. General first displacement, stress to strain. Most of particular deformation measurements instruments for measuring deformation that is compared to small changes in the axis, diametrical borehole gauges, deformators, extensometers, fluid levels, and surveying instruments. The change in the length measurement may be range from the less than 100 micro inches. The borehole measurements, the number of feet in the case of surfaces substances. So deformation units are made on surface of solid body and change in length divided by the distance between the measuring points. The resulting average strain between these points is the evidence that the strain gauge are inherently deformation measuring devices. However, customs have established them as a separate class of instruments. They are treated accordingly in this book. The surveying instruments such as the level accumulated tachometer and transit have been used as regular vertical units. Both in surface over the mined area and in underground workings. In some instance, the movement of the substantial as, for example, in the substance area for overlap, block caving operations for large voids are caged on the surface in over deposit mined by the long wall method. The following which are surface cavings in fixed facilities top area. For these large deformation, and accuracy, 0 is very sufficient, and this accuracy can be achieved with the most conventional surveying instrument without difficulty. Surveying instruments have also been used for measuring the compared to small lateral and vertical distance over the mine area. Preliminary failure, this displacement may be from the order of fractions of
any inch and accurate level, chaining, uh, chaining and triangulation measurements required to the level. So, according to that, similarly in the underground, most of the dial gauge deformities, most of them due to the two walls in the ground, exclude rulers, uh, exclude rulers and tap mechanical simulated deformation measure devices or deformity. Also, extension meters, which convergence gauges are specially typed. This class of instrument usually consists of length sensing devices such as a vernier scale, micrometer head, dial indicator attached to the end of the rod. Sometimes incremental instrument length. The sensitivity of the instrument, general institution meet the measurement requirement those in the roof to the floor convergence pole. Other related to weak flat beaded rock may be amount to several inches. Convergence gauge may consist no more than the steel scale read in the index of the rod. The sensitivity of such instruments would be about 0.01 in the magnification unit, uh, and the range several inches. Um, Describe the recording the type of convergence consists of two string on which hard rock mine the roof and floor convergence may account to only fraction inch to the current case for this type is to require a sensing elements such as a micrometer, the head or dial indicate provide the satisfaction. The end of the deformity can be permanently anchored, then an accuracy compatible with the gauge can be achieved. Moreover, this type of illustration will have an excellent time stability, especially if temperature corrections are made for the expansion or contraction of one. However, in many instances, magnet installation is impractical because of possible damage of instruments for many operations. So, instead which is deformation measures were made with strut ground or with floor. The floor strut had a hemisphere and the roof stand that is.
So this is the one type. And also, these techniques can give the our prior idea to the so prevention of these things. Most of the we have stress relief restoration techniques and deformation identification or sensitivity is used. Different sensors are present using. Half movement, there is every mine is also established. The what you called rock mechanics cells are also established in every mine also. That also the indicating what is measurements are going on in the situations accordingly. So I hope we are understanding what are the measurements of this type of techniques for the stress and stress relief of these things. I hope that you will understand. Thank you.